Hello, today I'm going to be going over TryHackme's web application security room, and just like my other videos, this is going to be more of a demonstration than an explanation. However, I will go through the tasks briefly and look at the information that's inside of them. So hopping right into task 1, the introduction, it talks about how a web application is like a program that we can use without installation. I'm sure that everybody watching this video is familiar with what a program is, but if you're not, it's something that run on our computers using the computer's processing power and storage. An example of a program would be Microsoft Word. Scrolling down, it gives some examples of web applications such as webmail like Gmail, online office suites like Google Drive, the Docs, the Sheets, Slides, and online shopping. And there's thousands of more examples of web applications. If you're at all familiar with the internet, you have interacted with web applications in some way or another. And then it talks about how the idea of a web application is that it's a program running on a remote server. And in case you don't know what a server is, it's a computer system running continuously to serve the clients. Clients, in this case, would be referring to users trying to connect to it. And in this case, the server will run a specific type of program that can be accessed by web browsers, such as Google Chrome, Firefox, Safari, that kind of thing. And then they kind of give it an actual example of an online shopping application and about what it does. The web application will read data about products and their details from a database server, and a database is used to store information in an organized way, which could be information on products, customers, invoices, etc., etc. A database server is responsible for a lot of what web applications use, such as reading, searching, and writing to the database. And an online shopping web application might need more than one database to access. And they actually give a very good graph showing like an online shopping web application here. And it has 3 different databases: a products, a customers, and a sales database. And they all tune in to the online shopping web application that users would interact with, and I'll go over this image. So this gives the fictional scenario of somebody searching for an item on an online shopping site. So, and this is very, very simplified, but the user would search for an item. Let's say they're looking for cat food, so they type in cat food on the item search on the web page. Then it'll search the database for results. Once it finds those results, it will bring it back to that online shopping web application, and it'll display that for the user. And from the user's perspective, all they would be doing is just typing in cat food and they get a result. And then it also kind of shifts focus and talks about bug bounty programs, which is basically just a way for people who find vulnerabilities to make money. They report those vulnerabilities to the companies that have them, and they get money for it. And hopping into the questions, what do you need to access a web application? Well, you would need a browser of some sort. You need other things too, like an internet connection, but in this case the answer is browser. And again, a browser is like Google Chrome, Firefox, Safari, etc. Moving on to task 2, web application security risks. Now this kind of goes into the risks that are possible when you buy something online and different routes and vectors that an attacker could use to hack and gain information or money. Here, it gives kind of an example of the process that it would take if you buy something online, like logging into the website, searching for what you want to buy, adding it to your cart, specifying where you want to go, and then providing payment details. This is kind of the process that you'd use when ordering something online, and it goes into some of the possible vulnerabilities that could arise in doing that. So, for example, even with just logging in at the website, an attacker could try to discover the password by trying a brute force attack, which is just a long list of passwords with an automated tool to test them against the login page. On number 2, searching for the product, the attacker could try to breach the system by adding specific characters and codes to the search term, and in this case, the objective is for the target system to return data that it should not, or execute a program it should not. And providing payment details, they may check to see if payment details are set in clear text or using a weak encryption. And in this case, encryption refers to making the data unreadable without knowing the secret key or password. This room is more so an overview. A lot of these terms, if you're completely new to this, you won't understand. and that's a-okay. They have lots of rooms that go into each of these categories and what they mean. Scrolling down, it talks about identification and authentication failure. Identification just refers to the ability to identify somebody, so this could be like an ID number, like you could be ID number 001. By contrast, authentication refers to the ability to prove that you are who you say you are. So for example, you might have a smart card or something that you scan and only you would have that. You could use that to authenticate yourself. And here they talk a little bit about the online shop must confirm the user's identity and authenticate them before they can use the system. This could be done with like a username and password kind of deal, but it's still vulnerable to brute forces, the user choosing a weak password, or just it storing the user's password in plain text. Scrolling down a little more, it goes over broken access control, which is when somebody has access to something that they shouldn't. So, and they use the example of someone in the marketing department has the ability to read the finance department's documents. And they talk about some vulnerabilities that are related to access control, like failing to apply the principle of least privilege. Basically, you want to give people the least amount of privileges possible. Just give them the privileges that they need to do what they need to do. Another one is being able to view or modify someone else's account by using its unique identifier, or being able to browse pages that require authentication as an unauthenticated user. And scrolling down a little more, it talks about cryptographic failures. Cryptography is its own section, just like everything in this room so far. Going over just kind of over briefly, cryptography focuses on the process of encryption and decryption of data. Encryption is scrambling clear text into ciphertext, which is basically just gibberish to anybody who doesn't have the secret key to decrypt it. And it gives some examples of cryptographic failures, such as sending data in clear text, relying on a weak cryptographic algorithm, or using default and weak keys for cryptographic functions. And don't worry if these techniques look challenging or sophisticated at first. TryHackme has dedicated in-depth rooms to help you understand and experiment. Again, this is just kind of a brief overview, which is why I'm not going in depth with them. I want to get more into the demonstration portion. Going to the questions, you discover that the login page allows an unlimited number of login attempts without trying to slow down the user or lock the account. What is the category of this security risk? So that would be brute force. And if we go back up, that would be identification and authentication failure. You notice that the username and password are sent in clear text without encryption. What is the category of this security risk? That would be a cryptographic failure. All right, and going on to task 3. This is the practical example of a web application security. So I'm going to go ahead and view the site. And specifically, what they talk about here is investigating a vulnerable website that uses insecure direct object references. And this would fall under the category of broken access control. And again, broken access control means that an attacker can access information or perform actions not intended for them. Going back to that example of someone in the marketing department able to read information from the finance department. But here it gives the example of somebody has the permission to access this photo. JPEG is a photo file, and it's IMG 1003, and then somebody might guess that there's 1002 and 1004. However, even if we type that in and try to view those, we shouldn't be able to if it's set up correctly. A insecure direct object reference occurs when we're able to type that in and we're able to view it regardless. And here it kind of goes over that again, where it says just providing the correct URL for a user or product does not necessarily mean that the user should be able to access it. And it gives this product page as an example, and that product ID is 52. Maybe that's the cat food that we were talking about earlier. So they plug that in and they're able to see the cat food and they're able to provide details about it. And a hacker might believe that items would be assigned sequentially. So there would be a 51 or a 53. By changing this to 51 or 53, a hacker should not be able to view ID 51 or 53. But if it's set up incorrectly, they would be able to. So that's a vulnerability. And they just kind of go over that again with the ID changing, and they might try other numbers such as 001.txt, looking for text files, that kind of thing. Anyway, let's really hop into the example that they have here. We will see a page showing an inventory management system. If we clicked on the planned shipments tab, we will discover that an attacker has managed to mix things up as part of sabotage plans. Notice how they send the wrong tires to each assembly line. For instance, they assign scooter tires and motorcycle tires to bike assembly. Yep, motorcycle and scooter. That's wrong. If this is left unfixed, all the tires will go into the wrong assembly. So we have to hack the system back and undo the attacker's steps. On your activity, you can see the activity of one of the users. And we also have reason to believe that this website has an iDoor vulnerability. So, going back to what we were talking about earlier, if we look up here, we can see that it has user_ID equals 11. So, what would happen if we change this to ID 1? It changes to somebody else. This is an example of an iDoor vulnerability. Going into the questions, check the other users to discover which user account was used to make the malicious changes and revert them. After reverting the changes, what is the flag that you have received? So at this stage, what I'm just going to do is brute force it. I'm just going to backspace, put 2, backspace 3, and I'm looking at this recent activity. This is where we'll see to revert the changes. Oh, and there we go. Let's go ahead and revert all their actions, and we get our answer to the question. And I'm Control-Cing, Control-Ving to paste that in, and that's the room. Very short and quick, but I hope that you enjoyed. Like if you liked, and subscribe to see more. Thanks, and have a good one.